Hey everyone, welcome to this guide on deploying local AI on a NVIDIA Jetson AGX Orin. We'll start off in the jump host where you should have already downloaded and installed the SDK manager. You'll need to log into the NVIDIA portal to get that. Now let's select a device. So you'll be prompted for what the device is connected and which one it finds. The defaults you can leave as is. For the actual components, make sure to also enable CUDA and CUDA XAI. The other ones are optional, but you can of course select them. The more you select, the larger the footprint will be. Put in your root password and the flashing will start. You will be prompted for a couple of things, so the configuration of the device and how it's connected to it, but we'll get to that in a second. I've sped this up quite fast, so this will take around 20 to 30 minutes if you do this yourself. Now, because the device is already connected in recovery mode, we can just select the pre-config, put in a username, a password, and in my case, I have an NVMe drive connected, so I'll be selecting NVMe for my storage. You can use the internal eMMC device, but I believe it's only 64 gigs or whatever amount that is. However, it's not enough for the AI models themselves, so I've put everything on the NVMe drive itself. This process will be faster, by the way, if you maybe do a couple of flashes after each other, because the download is what takes most of the time. But once everything is downloaded on the jump host, then it does bring down the time quite a bit. Here I've got my device connected via USB, so we can leave the configuration as is. If you have a pre-deployed device and you just want to upgrade via SSH, then of course you'll need to configure those things separately. And now the installation is done. Let's switch to the Jetson AGX itself. So make sure you have a display port or HDMI connected so that we can log into the device and continue the setup of the Ubuntu OS on the device itself. You can skip through most of the components, unless of course you want to set up your cloud account and stuff like that, but in most cases you don't have to. And when we're done with that, let's open the terminal and check to see which interfaces are found and connected. This is just to make sure the USB device is disconnected as well, or that the USB cable is disconnected. If you see the L4T bridge, that means that the USB cable is still connected to your jump host, and make sure to remove that and then restart the device. You might also want to change the power mode before doing this. So I believe the default it starts at 30 watt. You might want to put it on its maximum power to of course have the maximum performance out of the device itself. But of course you don't have to. In this case, we're just making sure that the USB cable is removed and that the device is rebooted because we will be installing the agent and connecting it to Palette afterwards. And if you have the USB cable connected, it will pick up the wrong interface. And of course you can configure specifically which interface you want to select, but that just adds extra configuration. So you can do either or. Now the device is rebooted, let's log back in and do some final checks before we go. But we don't have to do everything in here, so we'll be SSHing into the device after running some checks. Here you can see that the bridge for the USB is disconnected and we only have one ENO1 interface available. Now let's SSH into the device itself, because that will make copying things a lot easier. The first thing we'll do is, we can check what we just saw on the device itself already, and then let's make sure to update to the latest packages on the device. Of course, I've sped this up quite a bit as well. When that's done, let's install some tools, so Python 3 pip and the Jetson stats. With that, we can then run JTOP to see some information from the device itself, which is pretty useful. Of course, you don't have to, but I find it pretty useful. If you can't run JTOP initially, of course, you can try to reboot and restart the systemd service, but well, a reboot is typically faster. Now that we've rebooted, you can see here that JTOP then shows us the hardware information itself, GPU info, CPU info, and a bunch of other information that's pretty useful to track as we maybe deploy models to see what the actual load on the device will be. Here you can see I've put mine in 50 watt already. If you need some extra information about the drivers and CUDA versions and everything that's running, of course, you can run NVIDIA SMI or Tegra stats to get the live info as well, similar to JTOP, but then in text. And now let's do some pre-deployment of some packages that we need. We'll need those packages to install the agent itself. You should have gotten a token as well, so we'll need that token for this user data file that will be put in by a variable. This user data file just points everything into a specific folder, and it points to your palette instance project and adds a Kairos user to the agent that gets installed. Now we'll point the user data file in this specific directory, and then the CLI or the installation script can then pick up that user data file to then deploy the agent itself. So here we're just putting the script, changing the mode, making it executable, and then we'll run the palette agent install script itself. All of these commands, of course, you can get from the blog that belongs to this video. During the installation, the device is going to reboot. You'll see as well that the hostname that you selected or put into the user data file, that will be picked up as a new hostname or any other settings that you've configured. Because of course the agent will be able to make changes to the underlying OS as well. Here we'll just run journalctl to see if everything runs and spins up smoothly, because if something does fail, this is where we'll be able to see if maybe the agent restarts for whatever reason, or maybe a configuration is not correct, or the format is not correct, or anything like that. So I typically watch this in the beginning as well, and then switch to palette to check if it connects to the if the agent connects to palette itself. In palette, we'll just be able to see in the cluster tab, edge host, we'll be able to find that connected device. In this case, of course, this is then our Jetson AGX with one disk in my case, and then two NICs that it found. But of course, we'll only be using the E&O one. If you want to enable the remote shell to the device, you can. You can use the username and passwords that's already set, or you can create a temporary user. And then, because you might not have a user deployed with the agent configuration, so you can always just enable the temporary user to connect to the device. And of course, disable that when you're done with that. So this allows you easy access to the edge device if you ever need to debug anything straight on the device itself. Of course, that user will be added to the Ubuntu OS as well. Now that the device is connected, let's create the cluster profile for the infrastructure that we will be deploying as part of the Kubernetes cluster. Well, let's call it, give it whatever name you'd like. In my case, this is the name I've chosen. Select full for the type, because we will be deploying a couple of infrastructure components and one add-on component. Select Edge Native, select BYOOS for Edge, and then in here, we'll need to select the preset for agent mode, because this is not going to be an appliance mode, which is immutable, which is also supported, but agent mode is a lot faster on ARM devices or brownfield deployed resources. You can see the appliance mode. Like I said, that's immutable. So you'll need to build an immutable image and then flash that on the device itself. When you'll then have full control over that layer. And agent mode allows you to just run an installer script on an existing device and then connect that to Palette. So you've got full control over what type of deployment you want to actually, well, deploy. We're going to add some extra config to this BYOS layer because we need to add the NVIDIA runtime, or it has to pick up the NVIDIA runtime. So the original container dconfig.toml is going to import anything in this folder. So we're putting in an NVIDIA toml to make sure that that runtime is also imported. For the Kubernetes distro, I've chosen Palette Extended Kubernetes, disabling the OIDC integration. And the only thing I'm changing here is the pod and service subnets because I don't want them to overlap with my 192 subnet. So make sure that that's the same for you as well, or whatever you're using. Same for networking. I've chosen Flannel, and I'll make sure that the pod cider matches the pod cider I've put in the Kubernetes configuration. And then we'll need some storage. So in this case, I'll choose a simple one, local path provisioner, and checking that the storage class and the default class will be set and created. This will be our infrastructure profile, or well, mostly infrastructure. And then we can use this profile to then provision the Kubernetes components and, well, the software stack on top of that. So select create new cluster, edge native, give your cluster a name. Select your cluster profile. Of course, you can make last minute changes if you'd like to, but in this case, we just created it, so I don't think you'll need to. But of course you can. Or add any extra add-ons if you want from this point. For the VIP, for the Kube API, I'll just select the IP address of the interface on the device itself. So the Kube API will be using that exact IP address as well. It'll be a single node cluster, so it will have the worker capabilities. I'll select the ARM64 architecture, select that ARM64 device, the NVIDIA Jetson, and then for the configuration, I'll make sure to just select the interface I want to use, specifically myself. It might pick up the correct one, but I just want to make sure that it picks the one I want it to use. And we don't have any other worker devices connected, so I'll just remove that worker pool. Let's check the configuration one last time. You can, of course, enable scans, backups, set RBAC, and set a certain location. For edge devices, of course, you put in a location yourself. In my case, I'll just choose some city that's close to me, which is Amsterdam. This is then the overview, and then if we then finish the configuration, it's going to create the cluster on the device itself. In the bottom right, you'll see the actual screen. We can select the component we want the events to log from. So the event logs from the agent from the device. And we can see here that while the agent is deploying, the device is installing and rebooting itself, and then configuring, of course, then the components needed to then deploy the cluster itself. So the agent's just doing its work on the device itself. And of course, then if we check the state of the profiles, in the meantime, let's just create the profile for local AI. So the add-ons that we'll be deploying on the cluster while the cluster is creating anyway. So in here, we'll select then add-ons as a type, and you'll first need to make sure that you add the Helm chart repository for the NVIDIA device plugin to be able to select it from this registry. But in my case, I already have that, so I can select the registry, but let me show you how and where to do that. So you can get the information from their website, but basically you go to the registries tab, Helm registries, and then you can add any external Helm registries, in this case, the NVIDIA Kubernetes device plugin chart repo. And then once you've added that with the name you've selected, let it sync for a second. And when that's done, you can then select it as part of the layer for your profile as well. I've copied the full configuration from the content that's provided in the blog as well. So you can get that content for the values.yaml from there as well. In this case, I'm just making sure that the order is set to 1 because I want this to run first. And now I'm checking the configuration in the values.yaml to make sure that my runtime is selected correctly and that the necessary mounts are also correct for this specific device. And you can see the NVIDIA runtime here is then also selected for the runtime class. And then we'll be adding the local AI manifest. Same thing here, so give the layer a name, then add the manifest itself. Make sure that that's, let's say, a higher number than 1. This will also make sure that the first order, or order number 1, will have to completely finish before the second one gets deployed. So it might take a minute or 2 before then the second layer deploys. You can get this content from the blog as well. So put in a namespace, a persistent volume claim, make sure that the runtime class is NVIDIA as well to leverage the GPU. This is the image I'm using in this specific resource. And of course, we'll be using a node port, and we're adding a runtime class to the cluster as well, or else we'll get an error that it won't be able to find that resource. That looks good, so let's finish the configuration. Let's go back to the cluster and see how that's doing. In the cluster, of course, like I said, you can get the event logs from the device itself or from the cluster itself. In this case, the cluster components are then logging what you're seeing here. And if you select component and the device, you can get the agent logs from the device itself. The cluster is pretty much up and running. As soon as the Kubernetes API or the kubeconfig is loaded, we'll use that kubeconfig to then access the cluster directly using K9s. Of course, you can use whatever terminal or Kubernetes client tool you want to use. K9s is my preferred tool for that. So I want to show what's happening in the cluster as we deploy the profiles. So everything already looks up and running. So if you go back to the profile, it might take an extra minute or 2 to fully reconcile, but everything looks good, and our agents will make sure that everything is indeed up and running before saying that the cluster is healthy. Here we can see that the node only has a couple of labels because we will be adding the device plugin, and that will scan the device itself and then see what labels it can then add to your Kubernetes cluster. And then you can leverage or configure a resource to then use those specific, to match it to a certain label on a node so that your workload only runs on the node that has that specific label. So we can see here that those components are already pretty much instantly starting to deploy. Like I said, for the next layer, it might take a few minutes because it's going to wait until this is completely done and healthy. But in the meantime, you can see it's already deployed. It's already added a bunch of labels to the node itself. It's only one node, so that's fine. But this is the device plugin labeling the node with all of the components that it's actually finding on the device. And of course, you configure the device plugin to maybe find other resources depending on what your requirements. I sped this up a bit because it's going to wait for the next layer, but here we can see then it already starts to deploy local AI. This also takes quite some time. So as local AI deploys, it might take almost 5 minutes to fully deploy, but just be patient, it will come up. Unless, of course, there's errors, but if it's in this state with logs actually being generated and nothing failing or runtime classes missing or anything like that, then of course it'll be fine. Just wait for that to happen. In the meantime, I'll open up the JTOP to then be able to show the actual GPU usage when we start deploying the AI models and using it, basically. So let's go back to the cluster and see if local AI has spun up. We will, of course, get the node port service as well, as you'll see on the left side in palette under services. If we then select the node port service, it will open up the local AI UI. In here, you'll be able to then go to models to select and deploy your models. depending on the size of the model, it will of course take a lot longer to either download and of course load into memory and work. In this case, there's nothing yet. There's also no backends deployed. However, each model in most cases will also install its own backend. And when we're done, we'll be able to open the chat and then actually talk to the model itself. To make it a bit faster, I've selected Mistral with 7 billion parameters. So this is a pretty quick install and also pretty, for a small model, a pretty useful model, which you'll see in a few seconds. So this will install the model itself and the backend. So you'll see the backend logs as well. It doesn't always work immediately after installing the initial backend, but you'll see that when you try to use the model, if it doesn't do anything, then we might have to reinstall the backend. Here you can see that it installed the Llama C++ backend itself. And if you want to then go to the chat tab and talk to our model, you'll see that when we put in a prompt, it only shows a couple of lines in the logs, and it's also not doing anything, as you see on the left with in the send message. So we can immediately start sending a message. So if you see this is not loading correctly. So just go to the backend and reinstall the backend, and that in most cases does fix the problem. So just go to your Llama C++, reinstall, and then go back to chat, and then let's try it again. Again, depending on the size of the model, this will take some time. So the initial 1, 2, or 3 prompts that you do, those will take a lot longer. Here we can see that it's actually loading the model and it's actually doing something, and we can see the progress bar actually loading as well. So this is what it's supposed to look like, and that's good. Here we can also see that the GPU memory is then also being allocated, and the GPU is also being leveraged before we then get our first response. In my case, I sped this up a bit. So like I said, the initial response might take a minute or two, the second one as well. But the further you go, the faster the responses for your model will be as well, as it of course gets loaded into memory. Here you can see that it takes, I sped it up a little bit just to show you that it does take a while for the first and second response. And then you'll see that the third and fourth are going to be extremely fast. So the model is responding correctly to my queries, and we can see the GPU usage on the right. So yeah, start off with something simple like, hey, do you know any good jokes? And of course it does, but then we can get serious after that. And of course you can play around with these models as much as you like, which of course everyone does, right? Ask it if it's Skynet or anything like that. I've just kept it simple, and I'll just ask it for the meaning of life. So that's pretty simple, right? And of course you can leverage these resources and implement this type of deployment, this type of hardware in branch offices, on site, for demos, for whatever project you would like to have a local inference for your AI models. And then of course you can use smaller or bigger models depending on what you need, or models that can do image recognition or object recognition or text to speech or anything like that. So you can choose, there's a whole lot of models to choose from, and you can choose whatever works for you, and whatever it is then, well, whatever will be able to work on a device like the Jetson AGX. Because of course you might not be able to run the biggest models, but you'll be able to do a lot of local AI inferencing on a device like the Jetson AGX. Of course, yeah, this is me just playing around with the model itself, trying to trick it to say something stupid, but of course it's not going to, or at least not yet. But for me, I'll just stop here with the queries. So of course you can download other models, test different configurations, different setups, different solutions and tools. However, this is just to show that you can easily deploy a Kubernetes cluster on a device like a Jetson AGX, and then deploy the workloads on top and leverage local inferencing for your AI models or whatever you'd like to use on the device itself. So this makes it very simple to run things in branch offices, like I said, on site, demos, conferences, without having to have a cloud connection or pay for a subscription to an AI. And as you can see here, I just simply deleted the cluster and the device becomes available and healthy again so that I can provision a new cluster. So thanks for watching and see you on the next one.